take a look at this VP110. So I got Python here. And so it's already running a Python environment. So I can set I equal to 1 and print the variable I and the type of I, and j is I plus 1. So it's going to spin up a containerized machine for me to use. Now it's ready. So I is 1, that's an integer, and j is 2, and that's an integer. So this is pretty obvious. Now we're going to define bytes. These bytes objects are like strings. You put them in quotes, but you start with a B. That makes it a bytes object. And you can put either a printable ASCII character to get the ASCII version of it, or you can put in a \x, and that will be a literal hexadecimal value. So this byte is going to be the hexadecimal value 1. And so there it is 1 class bytes. And when you try to add 1 to it, it's going to warn you, you can't do that because you can't add an integer to a byte's value. And A is not an integer, it's a byte. You can't add 1 to it. Now, if you wanted to add 1 to that to get to 2, you could do it this way. The bytes object is actually like an array. And so if you set the value A, which is defined here as a bytes object, A sub 0 is going to be the value of the first object, which is an integer, and then I can add 1 to it. So that gets you back. This is an integer, the first element of the bytes array, and now I can add to it. So that's one way to go. And so if what you wanted to do was get to the bytes object called 2, you'd have to do it this way. And this is why something I've said many times is it seems to me in Python, I spend about half my life converting variables from one type to another. There are quite a few variable types, and you keep having to convert from one to the other. So here I define a bytes object called 1. Then I define B to be the integer value of the first element. Then I add 1 to it, and then I turn it back into bytes. So I finally create a bytes object that contains 2. And it takes a few steps to get there. All right. So now we can try files. So first let's create a file containing this text. And what I can do in this Colab environment is I can use bang, and that will let me execute bash shell commands. So I can echo hello to that file, to, I'm calling it infile. All right, that should do it. And I should be able to verify it. This will let me see my files and see there is a file called infile. All right, so that's created, and that contains the word hello. So now I can read it in Python. And this is one of the ways to do it, pretty nice way, with open infile to read binary as f. F is a handle to the file. And now, while the file is open, I indent, that's all this. Then I open an out file as g. Now I read the bytes one by one, and while the byte is not null, which is the byte with nothing in it, then print it and write the output. So this will create another file called out file, and it will also print it on the screen. So I run that, and there you go. Here's the bytes, HELLO, and the carriage return at the end. That's what it found. And so now there's going to be 2 files, in file and out file. All right. So that copies a file. And so there are a few flags you can practice here. Here you can read this file, which contains a whole bunch of bytes, and you have to count the number of bytes that are 8s. And here you have 2 files, byte by byte, and you have to add the bytes together and make one file with the final total of those byte values, and they'll add together to a readable string. And here's another one that's bigger, where after you combine them, it's going to make a viewable image after you add them together. So there's a few examples there of VP110, where you just practice handling bytes, integers, and file I/O. And that's all there is to that one.